Hi Titans, hello and welcome to Chapter 5, Section 5. Here in Chapter 5, Section 5, we are studying standard and point slope forms. In Chapter 5, Section 5 in Algebra 1, we mainly focus on standard forms. Point slope is something we will discuss in class, but the main focus is standard forms. So let's go ahead and dive into Chapter 5, Section 5. So for today, the first thing we're going to talk about is a linear equation and how it may come in any form. We're going to talk about how the best form for graphing is slope-intercept form. Standard form is a new form that we will introduce to you today. Standard form also has many uses, especially in upper-level algebra. Today we will focus on changing equations into different forms. And we will also focus on the third method of graphing, which is by focusing on intercepts. Let's jump right into what standard form is. Standard form is when the x and y term are on the left side, and they're set equal to the constant. For example, 2x plus 4y equals 8 is in standard form. The x and y are on the left side, and they're set equal to the constant. 5x minus 7y equals 12. Once again, that's in standard form. The x and y are on the left side, the number is alone on the right. And then the last one, 3x minus 9y equals negative 18 is in standard form. The x and y are on the left, and the number is isolated on the right. So as you can see, standard form is anytime an equation is in the format of ax plus by is equal to c. Now standard form has its uses, but in terms of graphing, it's not as useful as slope-intercept form. In slope-intercept form, we can identify the slope, the y-intercept, we can plot those, and make a graph. We cannot do that with standard form. So it's going to be useful to us if we have the ability to go from standard to slope-intercept. So keep in mind that in slope-intercept form, the variable y is isolated. So what we're going to want to do with these standard form equations is solve for y, meaning isolate the variable y. Let's jump into an example. The first example we have for you here is 3x plus 6y is equal to 18. Now to put this into slope-intercept form, we want to get y by itself. So to get y by itself, the very first thing we're going to do is take 3x and move it over. When 3x changes sides, it's going to change, you guessed it, signs. So we will be left with 6y is equal to a negative 3x plus 18. Now this is not in standard form yet, because, it's not in slope-intercept form yet, because the variable y is not isolated. So to get y by itself, I would have to divide everything by 6. Now I'm left with y equals negative 3 over 6, can simplify to be negative 1/2 x, and 18 divided by 6 is 3. So now I have my equation in slope-intercept form. Y equals a negative 1/2 x plus 3, slope-intercept form. So let's review my steps there. Step 1 was to take the x term and move it over. When it changes sides, it changes signs. Step 2 was to divide to isolate the variable y. So as you can tell here, I have the equation in slope-intercept form. Y equals negative 1/2 x plus 3. Alright, let's jump into example number 2. In example number 2, I have x minus 3y. Let me erase that here. I'm not getting a friendly writing there. This will be better. Here we go. X minus 3y is equal to negative 6. So to put that into slope-intercept form, I want to isolate the variable y, isolate the variable y. So I'm going to take x and move it over. When it changes sides, it changes signs. So I'd have negative 3y equals a negative 1x minus 6. Negative 6 did not move, so it does not change. Negative 3y, it did not move, it does not change. My next step would be then to divide everything by a negative 3. When I divide everything by a negative 3, that's going to leave me with y equals negative 1 divided by negative 3 would be a positive 1/3 x, and then negative 6 divided by negative 3 would be a positive 2. Now I have my equation in slope-intercept form. So to put something in slope-intercept form when it's in standard, step 1 is to move the x term over. When it changes sides, change signs, and then divide to isolate your variable y. Once it's in slope-intercept form, you could then go ahead and take it and graph it. Alright, so let's look at one here. Graphing when given the equation in standard form. If you're given an equation in standard form and asked to graph it, what you'll go ahead and do is take that equation, and we'll just do the first example here. X plus 2y is equal to 6. And let's go ahead and graph that. So if it's given to us in standard form, we would want to go ahead and change it into slope-intercept form. So I would move the x over. When x changes sides, it changes signs. And then I would divide to isolate the variable y. And remember, we have to divide everything. So in slope-intercept form, the equation is going to be y equals a negative 1/2 x plus 3. So now I can graph that. I plot my y-intercept at 3. It'll be a little bit messy here graphing on the iPad, but be patient with me. And then my slope's a negative 1/2, so I go down 1 over 2, down 1 over 2, down 1 over 2. Or I could go up 1, left 2, and then I can draw my line. So that's how to graph when given it in standard form. So once again, I took my x, and I moved it over, changed sides, changed signs. Then I divided to isolate y. Then I had my equation into slope-intercept form, and then it was ready for me to go ahead and graph. That's one of the major skills from this lesson, and this is one we'll work on tomorrow in class. Alright, let's move on to the next part of our lesson here tonight. The next part of our lesson is the ability to find the x and y intercepts of a given equation. This is the third method of graphing. The first method of graphing is by making a x and y chart. The second method of graphing is using slope-intercept form. The third method of graphing is to go ahead and do so by finding the x and y intercepts. I believe this is a method that works very well with standard form. So here they ask us to find the x and y intercepts of the given graph. Now we've been talking about this in class a little bit. If it's in slope-intercept form, you can immediately pick out the y-intercept. But if it's in standard, you can't. You can't just sit here and say, well, 12 is the y-intercept. It doesn't work that way with standard form. If it's in standard form, you can graph by finding the x and y intercepts. So the very first thing you do is try to find the x-intercept. Now we've talked about this a little bit in class. To find the x-intercept, what you do is you go ahead and set y equal to 0 and solve. And the reason you set y equal to 0 and solve is because every point on the x-axis has a y value of 0. And an x-intercept is a point on the x-axis. So we can go ahead and set y to 0 and solve. So I always tell students, in this they can really just do the cover-up method. If you want to find the x-intercept, you know you're going to plug in 0 for y, so just cover up the y term and solve that equation. So what's the x-intercept? You guessed it, x equals 4. So on the x-axis, we know this graph is going to cross at 4. If you want to find the y-intercept, you could go ahead and simply use the cover-up method here, and you could cover up the x. Because you know that the y-intercept lies on the y-axis, and every point on the y-axis has an x value of 0. So if you plugged in 0, 3 times 0 is 0, so it's just basically a non-factor in this problem. So if we solve this remaining equation, you would divide 4 by both sides, and y equals 3. So your y-intercept is 3, and you can go ahead and graph that line. That is graphing using the intercept method. It's also called the cover-up method by many. This method is useful when you have an equation in standard form. Now, if we were to go ahead and do this equation by putting it into slope-intercept and then graphing, you guys would notice that we get the exact same line that we just got by using the intercept method. So whichever method you use, you'll get the same answer when working with this line. Alright, let's go ahead and try one more tonight, and this is using the intercept method. So the x-intercept, to find the x-intercept, you cover up the y term. So when you solve that, what's the x-intercept? 3. Then we'd go ahead and find the y-intercept. So to find the y-intercept, we're going to cover up x. So if we go ahead and cover up x here and solve, the y-intercept would be, guess what? negative 5. So y equals negative 5. So my y-intercept is negative 5. And then I can go ahead and draw my line. And I have my graph. That is the third method of graphing, which is the intercept method, or you may hear some call it the cover-up method. Alright Titans, that completes our lesson here for 5.5. Make sure you have these examples I went over down in your notes. We may add to these notes a little bit tomorrow in class. Also, come prepared with any questions you have, and trying to give a quick fill out to the Google form below, and that way we can get some feedback from you guys in terms of what you understand and what you do not understand. Thanks for listening, Titans. Stay classy.